Alright, so here are the notes from class today. We started off with our number line. Go over to paint here and draw you a new number line, as soon as I choose a color. I'm talking after I drew all of this, so if the video doesn't quite make sense with what I've been saying, that's why. So like we talked about, the number line is actually the x-axis. And when I have you draw a number line, I really just care about where the numbers are relative to each other and relative to 0. So like there, 3 is on the positive side, and 1 is in between 0 and 3, and 12 is on that side of 3. I don't really care that they aren't, proportionally the right distance. And remember on negatives that the further I get away from 0, the more money I owe you, or the more negative I get. So, like negative 28 is way out there, past negative 1. And then if I want to choose a number between negative 1 and negative 28, it's going to mean that I owe more money than negative 1, but I owe less money than negative 28. So negative 10 is a number that's right in between there. And if you aren't getting the whole money reference, kind of let me know, because I can give you other references too. And remember with the decimals that until you actually get to like negative 10, negative 9.5 there is on that right side of negative 10. And heading on to the next thing. Haha! Communicative property. So we're gonna go briefly over again communicative property, which basically shows you which operations communicate and which ones don't. And remember, the main thing is to remember how this works, unless the actual title communicative. Addition is communicative. 4 plus 3 is the same as 3 plus 4. Multiplication is also communicative. 4 times 3 is the same as 3 times 4. But subtraction, negative is, got it right, same numbers. Being negative is not the way to communicate. So 4 minus 3 is not the same as 3 minus 4. And division certainly is not communicative. So 4 divided by 3 is not the same as 3 divided by 4. Not at all. So you cannot just flip around subtraction and division, but you can flip around addition and multiplication however you want. And see there, I just was showing you again about how multiplication and addition are kind of alike, and division and subtraction tend to be a lot alike. And for this one, instead of just writing it again, I'm going to show you, just kind of draw on here with it. Remember that this whole thing here is a term, and this whole thing here is a term, that they're all one big group until you get rid of that whole parentheses and everything. That you're adding both of those big things. So if you want to do the communicative property, you got to move the entire thing from one side to the other, and not just part of it. And here are our identities. Remember, that's the number that you can do the operation and that it won't change the value. So the additive identity is 0, because you can add 0 all day. Subtractive identity is 0. You can subtract 0 all day. Multiplicative identity is 1. And the divisive identity is 1. You can multiply by 1 all day and divide by 1 all day. So remember, you can always add in your friends 1 and 0 if something looks really confusing. 1 and 0 are your friends. Well, mostly 1 is the one you're going to need to add in to things, or we're going to be using 1 a lot. So remember that we can always throw in that 1. And copied over our example from today. I may do it just slightly different here, because remember, right here we can throw in our 1 to make this look less confusing. And now, just for kicks, I'm going to turn this around just again to show you that communicative property about how we can, you know, change the addition around, flip-flop it if we want to. In this case, there's really, to be honest, no benefit to moving it around. I really am just doing this to show you that it's possible, and that if you were to be throwing things around with addition, how you would do this one. Because, I mean, if I were actually just going to solve this out like I got it on my assignment, I would just have distributed without switching it. But I'm showing you that it's possible to do this. So now, first thing in our PEMDAS is P for parentheses. So we're going to distribute, and 3's going to the party, and everyone's hanging with 3. So first we're going to do 3 times 4x, and then 3 times 2y. And we're going to pull that plus down there because we didn't change anything with that one. That one is exactly the same. The only thing we've done is brought 3 into the party so that the parentheses can go away. And now we're going to distribute that lovely -1. So that now that 2 becomes -2, and that subtract 5 becomes y, becomes plus 5y. And if it helps, you can even plus minus that. If, you know, that helps you see the subtraction, go for it. You can always change that. And I'm gonna circle up my x's there. Remember, x's and y's, apples and oranges. So I've had 12 x's and I lost 2 of them. I now have 10 x's. And how many y's do I have? 6 y's here and 5 y's there. Adds up to be 11 y's. Boom. There they are. And that is the whole answer. This isn't equal to anything. I didn't give you any other numbers, so, you know, you aren't expected to find anything else. And next, aha! Right, magic with the fractions. Woo! I like to say mathematicians are magicians because we like to make things look fun. And I'm going to talk about all the ways you can move this around. And again, this is just so I can show you how to move it around, not necessarily because I would do a lot of this. I was deciding whether or not to do a different fraction, but I decided just to stick with the problem I'd used in class. So, remember that the 7 plus 11 being on top there over the 9, that the 7 plus 11 are a group. That is the same thing as if you did the 7 plus 11 in parentheses there. And I'm going to catch up. Divided by 9. That's exactly what we're doing. It's exactly the same thing. And that you have to think of that everything on each side of that divisor line is in a group. You don't have to worry about parentheses for the 9 because all it is down there is 9. But if we draw parentheses and we throw our little 1 in there that we know we're always multiplying by, or that's our multiplicative identity, we can also just go ahead and bring that 7 plus 11 down if we want to. Why not? Just for kicks and giggles. And this is exactly the same thing. We can bring that down and leave the 1 up there if we want to. We can also remember that we can put anything over 1, so that 7 plus 11 over 1 is always possible, because that's our divisor identity. And then remember, when we multiply fractions, we multiply top by top and bottom by bottom. So we got 1 times 9 is 9, and 1 times 7 plus 11 is 7 plus 11. So we can put it right back on top if we want to. Ta-da! Then 7 plus 11 is 18, because we solve inside the parentheses first. And then 18 divided by 9, because it's still over that 9, that we didn't do anything to get rid of that yet. And 18 divided by 9 is 2. Boom! Same answer. And that's all that I had from those save notes from that particular class section of Algebra 2. But actually in a couple sections, there was a question about combining x and x squared. When we're adding and subtracting, especially, x and x squared do not combine. They are 2 different animals. It's just like saying, I had apples and accordions. They are just think of that x squared. Don't worry about the exponent on there. Pretend it basically doesn't exist. That basically it's just telling you this is x1 and this is x2. Thing 1s and thing 2s here. So I'm going to circle my -5 accordions and my 7 accordions over here. And if I combine those, let's see, 7 accordions and I lose 5, I only have 2 accordions left. Oh, less polka for everyone. Sad day. I love polka, by the way. Anyway, random note, but then I'm going to see, oh, I got 3 X's there, and they're both positive, so I'm going to add those two together, and that is the final answer. Do not combine those. And that's all I have for you tonight. Good luck, guys. Have fun.